Hi, everyone, and welcome back. This is our last session of the 5 that we have been doing. It seems like we just started in September, but nonetheless, here we are. This is session number 5, in which we'll kind of look at what we left until the May and June months to review. And also just keeping in mind that we're kind of at that point now where we are working through the outcomes that are still listed in our months to check for mastery, to check whether or not they've met the outcomes, because we spent most of our year going back over and bridging. So you're revisiting, always tooling up the different outcome that you're trying to target towards, but doing it in smaller steps and revisiting as we go. So today, what I'd really like to do with you is just do some more activities that would allow you to continue to revisit those outcomes at the level that they should be at right now for reporting. But we still have about 6 weeks that if a child isn't quite at that outcome, then we are able to still have some time to try and find where the gaps are and do some addressing as we go along. So I'm going to give you and share with you some sites. We'll look at a couple things that are familiar to you that you've seen before, but maybe looking at them from the lens that you haven't used them for a while. Or we're also going to talk on statistics and fractions, because we said we would revisit the fraction piece again at the end, especially to really unpack what it means to make sure that we understand what we're looking for. And then also the statistics, because we said we left that to sort of the end of the year. It might be one of those times that maybe you've already done it. Maybe you did something in science and social in which you included your stats unit in there. But if not, let's make sure that at least we all walk away with the same understanding of what expectations are in statistics, and grade 2 in particular, because you do something that everybody else is going to rely on. So let's get started. Let's begin with our land acknowledgement. We respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant community. So this is a slide that we're looking at right now. It's just a quick review. This is one that we did look at in session 4. And we spent a little bit of time saying, really, we're working now towards taking away any yellows. In other words, no incremental steps, and really looking at, are they able to do addition and subtraction to 100? And is that comfortable with regrouping and not regrouping? So we still have time to be working on that. Again, we said that money probably would be our best bet in order for us to make sure that students understand not only how to add 2-digit numbers, but I can combine that to place value at the same time. It's tangible, it's real, it's a context that makes sense, instead of just getting a worksheet that has 10 or 15 questions of double-digit numbers that I'm adding. That gives me something that's real. And remember, the reality check that we can offer students helps to embed the processes that we're asking them to learn and really ask them to explain their thinking. If it's in a real world context, it's a lot easier for me to make those explanations happen. So if we look at May and June, we haven't got any yellows because we are now, these are the outcomes that we're going to be reporting on. So remember, the ones with the numbers are outcomes, but the bullets are the understanding that goes with that component. And in this case, you have an outcome. It's the 4th row of cusps, and quantities can be estimated when exact account is not needed. So we're going to do an activity today with just a piece of string or with a piece of paper to show you how we might talk about unit fractions. So again, having just a way of measuring this that might be new, might be fresh to them, and yet I'm just doing the same outcome that I've been doing all along. We want students to explain addition and subtraction. So what is their strategy? How would they see where they needed to regroup? What did they regroup? Why did they regroup? So just the answer alone of adding 2-digit number together is not sufficient. That's great, we get the right answer, but what was their thinking behind it? Can they explain how they got that answer? Wasn't just by luck, wasn't a guess, didn't long neck it to somebody else, right? Want to know what the thinking is. Students students interpret whole relationships for unit fractions. So we said we would revisit this. We did unit fractions when we put the dimes on the number line. We did that already. We did that in session 3, but we want to revisit that because now we don't want to just do the 1/10, the number line with the dimes on it. We actually want to have more unit fractions. So there should be a good understanding already about what a unit fraction is in terms of the dime work that we did, how I hopped by 1/10. And when I did 10 of those 1/10 hops, I got to 100 cents because there are 10 dimes in a loonie or 100 cents. So we want to start making more of those connections and making sure they really understood what that was all about. And we're going to unpack what the knowledge, skills, and procedures are for that unit fraction to make sure that we're all working on exactly the same place. You might want to bring up your money app if you're working on it, because we'll just use that. We're going to work on a base 10 system, meaning we would like them to work with loonies, $10 bills, maybe a $100 bill. But that's that base 10 that we want. Okay, we want them not to have to deal with $5 bills, 5 cents, anything like that. We just want loonies and $10 bills, because that way I can have conversations about place value, but I can also tangibly see when I need to regroup a number, and I can physically regroup the number for something that I can understand, and that being money, instead of just using a base 10 block where I'm regrouping 10 little squares that are plastic for a rod, which is also plastic. I don't walk around with any of those in my pocket. I'm not saying don't use the base 10 blocks again. We're saying absolutely use them, but make sure they understand the process, and that process would come from money first. Okay, so let's move ahead here. I'm going to just explain this. So if you brought your money app up, we're going to use what we call the base 10 system, so loonies and $10 bills. And what I'm going to ask of you to do first, or we would ask with the students, here's just a quick check for me to see whether or not they know what they're doing. And I'm going to pick a number, but you can pick whatever you want. I'm asking you to show me $81. And in your first opportunity to drag out your $10 and whatever you're going to show me, you can do it any way you want. Okay, so show me $81, drag them out from your money unit. And again, any combination, as long as I end up with $81, I get to choose as the student how that's going to look. So you could pause the Visio right now if you wanted to and just go through and do that. In my example here, you see I have 10, 20, 30, 40, $51. And to that, I added 3 10s. And you're going to have students who are just going to drag out 8 10s and give you a loonie, and that's $81, and that's good. And some of them might put them all underneath one another and make them like their own row. Whatever, as long as it adds up to $81, they have met the outcome that we asked them to meet. So let's do it again. If you're going to use the same screen, just highlight everything, put them in the trash so that you can start clean. And this time I want you to show me $81 again, but I'm going to give you a starting number. So I'm going to say, I want you to start with $29. So $29 has to be one of your numbers. Now I want you to get to 81. So what will your other number have to be? So if the students are really getting good at double-digit addition, they probably are doing well in subtraction as well. So some students might say, well, this is a subtract question. So I might go 81 minus 29. Perfect. I didn't tell you how to solve it. I said, I need you to have one number to be 29. What is the other number that's going to get me to 81? So it could be an addition question, and some students might see it as a counting on addition question. So I have $29 down here. Again, let them work at it. Let them show you what they're going to do, whether they're doing it on virtually or whether they're doing it with the manipulatives. I might add one more dollar above this, and that takes me to 30. And that's easy, because once I get to 30, then I could put down a 10, which is 40, another 10, which is 50, another 10, which is 60, another 10, 70, another 10, 80. Oh, and you wanted 81, I'm going to put another loonie down. And then I could regroup all the stuff that's on my page and put the 2 loonies together, and I see that I have $52. And my question at that point would be, can you prove to me that you have the right number there? How will you prove that you actually have 81? Well, they could recount everything that they see here and show me that way. Some of them might say, well, I could add 52 and 29 together and prove to you that I got 81. So there'll be some regrouping. They'll have another 10 that leaves in a $1 loonie left over, and they will prove. But it's not just enough to get the right answer. So always go to that. Can you tell me how you got it? But that also helps us as teachers to recognize what is the strategy that they're using, or are they just by luck getting something? Or they're getting it thinking they have a good strategy, but their strategy has a flaw in it and could eventually end up with the wrong answer. So this just gives us a way to double check what is their understanding, how are they approaching it. So we're going to do it again. I still want $81, but this time the number that you're going to start with is $47. So you'll note that in both of the ones that I'm giving you, both of them have a regrouping. They're going to require regrouping some way, somehow, whether they do it as a subtraction or an addition. So again, a student might count up, put 3 loonies down, say I'm at 50. I'll put down 3 more 10s. That takes me to 80, and I need 1 more. So that means I actually need 34. So again, I can ask them, can you show me how you could prove that that's correct? Now you might have noticed that in the right corner at the top here, I had asked you to show me $81. I put this up here as a legend or as a tool for some students to help them. So you will see that sometimes if you do this for students, they will look at this 29 and say, all right, to get to 81, I need to take away all of this stuff from up here. So they'll actually use this legend of 81 as a tool to start removing things to see what's left over. So they might say, oh, I'll get rid of these 2 10s, so that row's gone. Now I want to get rid of these 9 loonies. Oh, can't. I only have 1 loonie. So I'm going to take this 10 and change it to 10 loonies and put them out here. And that means that these 3 were gone. And I'm going to remove my 9. That will leave me with 10 or 2 left over. And so I'll have 1, 2, 3, 4, 5, or 52. So again, it's another way for you to do it. And if you have some students that need a little bit of scaffolding, putting this legend in the top right-hand corner isn't a bad thing to do, right? It just gives them a prompt to get going. At some point, we might not want to put that there if we're doing a summative, because we really do want to get a sense of where they're at. But again, it's not giving them an answer in any way when I get to 29 and 47. I have to have a tool and a strategy that allows me to get from 29 to changing something in this 81 to give you the balance that you're looking for. So again, weigh it out and look at it. So as I mentioned, some students may read this as, I'm going to take what's in the legend at the top, and I'm going to make this a subtract question. So they'll change every one of those to a subtraction question, which in fact they could absolutely be. No doubt about it. Okay. So those are things that I would encourage you to do with your students now. Not only am I getting to see whether or not they can add or subtract 2-digit numbers, but I'm also giving them to them in a real world context. I'm seeing whether they can regroup. How did they regroup? They're regrouping with money. It's a context that's real. So I'm getting a whole bunch of things happening just with asking that simple question. I could also use my Cuisenaire rods, and I could use my Desitrax. So for example, I could build using both of the pieces. So because we're using to 100 now, not just to 50. I could have them build 81. So I'd build with 8 10s and then a 1. So the little white square. And then I could build 29. So here's my 2 10s and my 9, the blue. So when I say that I'm going to treat this as an overlap, what that means is it's saying that the 29 that I already have is already covered in this piece here. So if I were to pretend, take a saw and cut off the piece that's overlapped, what's left over, I can read it off, is how much I need to fill in to find that missing amount. So this is a subtract question. I could slide the 29 down to 0, and I could say, what do I need to add to get up to the 81? So they could add a 1. They could just see that they put a 1 in there, and then they use groups of 10s. They could add groups of 10s right away and add a 2 at the end. There's lots of ways to do this, but this is another visual way that makes sense to lots of students. So you might want to offer them that as a tool as well. Now, if you have some dominoes, and if you don't, you might even want to pause the video, go grab your subitizing cards and a set of dominoes. And what I want to do is I want to practice with the students. I want to know, do they know how to add a two-digit number together? But again, I have options here as a teacher. I can give you worksheet after worksheet after worksheet, which isn't exactly the most entertaining for a student. Or I could do exactly the same thing, only they don't realize that that's what it is. We're going to do it with a manipulative. So in this case, what I could do is have them turn over 2 dominoes and put them in groups like this. In fact, what you could do is take the dominoes and trace them sort of one over another like this. So you'd have a place for 2 dominoes stacked and leave enough room on the side for me to write down a number and actually do some work if I needed to. So that would be the symbolic version of it that we want. So getting to the algorithmic side of it as well. So what I'm going to do with these sets of dominoes is I'm going to try and just do quick reviews of a whole bunch of things. First of all, I might say to the students, once you've got them stacked, I want you to write down what 2-digit number do you have in each of them. So for example, in mine, I have 45. I have 63. So I would write down 45 and 63. Now, before I ask them to do anything, I might say, which number is greater or less than, right? Do the comparative language. So 45 is the smallest number. Can you give me 3 numbers between your lowest number and your highest number? And so they could write them down in a space below. So 3 numbers in between, kind of like the one that we did on the number line where they drew numbers out of a bag. Can they skip count from your lowest number to your highest number or get close to it by skip counting by 2s? So if I skip count from 45 by 2s, it'll be 47, 49, 51, so on. So I can say, can you skip count by 2s? And maybe write down 4 numbers, starting at the smallest. So to always have a starting place. Can I skip count from the smallest number by 5s? 45, yeah, sure. I get 50, 55, 60, 65. No, can't do 65 because that's bigger than what I have. So I have to stop at 60. Can I skip count by 10s? So 45, 55, yep, that's where it stops because the next one will be 65. So again, I can just revisit a whole bunch of outcomes and just do them that quickly, always keeping them fresh in their minds so that they're actively doing that. And now I can say, can you add these numbers together? So what is 45 plus 63? Well, I could use this part if I wanted to. I could say 5 and 3 is 8, and I know that 10 and 6 is 10. So my answer should be 108. But I could do it symbolically over here, 45 plus 63, and there's nothing to carry here. There's nothing that I have to regroup. So I will end up with 108. So again, I can do this all over. And what makes this appealing to students? It's appealing because I don't have the same number that my partners do. If I'm sitting at a desk with rows or more than one person at a double desk, then I get to be in charge of what I turn over. The most common question we hear from students when we do this activity is, well, which way should I turn the dominoes? Like, do you want the biggest number first? Do you want the smallest number? And we just say, it doesn't matter. You choose. You get to pick. You pick your numbers, put them down. Once you put them down, that's where they stay. And so I could do this with this order, but then I could come back and say, could you turn them around? Could you just take the whole thing and turn it around? So then it's going to be 36 and 54. 36 and 54. Those are my 2 new numbers. When I add them, will I get the same answer? Some students will initially first say, sure, because they're the same dot patterns. Say, check it. Tell us, is it the same? So what's your lowest number? What's your highest number? What's the greatest number? What's some numbers in between that? Can you skip count by 2, 5, 10? Could you skip count by 20? Could you skip count by 50? Like, think of all the skip counting that I have to do, depending on the size that I have, right? So they would go through this. So I'm now doing a worksheet in the same way that I would if you gave me a whole bunch of numbers, only this is generated by the student, and they get to pick how the order appears. And that is empowering for students, where they think they're in control of the numbers they see, and for whatever reason they want a certain order. Great. Doesn't change anything that we're going to do with them. Same thing with your subitizing cards. Now this is one format. It's still subitizing because I still have to recognize these numbers without counting them individually, but the pattern is the same. They are all dot patterns. And if I use the subitizing cards, do the same thing. Just give them a pile of subitizing cards and call out any number that shouldn't be there. Put them into squares like this. So they just turn over 4 in the order that they want. They could go 1, 2, 3, 4. They could go 1, 2, 3, 4, whatever. As long as they have 4 of them facing up. What is the 2-digit number that is formed here? In this case, it's 35. What's the 2-digit number that's formed here? It's 38. But notice what I have to also do as a student. I have to subitize different visuals of a subitized value instead of just the dot patterns. So 35 and 38, which is the smallest number? 35. Can you give me 3 numbers that are in between? 35, well, 36, 37, next one's 38. Nope. I turned over something that was a very small range. Can you skip count by 2s? 35, 37, yep, then I have to stop. Can you skip count by 5s? Nope. 10s, nope. Anything past that isn't going to work. So it's the luck of the draw, right? Whatever they come up with. And once they've done that, you could turn it and say, I want you to turn the cards, just take them a 90-degree turn counterclockwise. So this one will be over here. This one will move up. So now I have 58 and 33. I could ask the same thing. So I don't even have to change the cards, but they like fresh, so give them new cards. That's fine too. This is a great way for us to do addition. It's a great fun way for them, and they are still meeting the outcome that you're checking for. And if they consistently did these correctly, you can say that they've met their outcome. I don't need to wait till June to say, yes, they've met the outcome. They consistently show me questions like this. They can tell me larger from smaller. They can do the addition if they need regrouping. They know what to do. So those are the pieces that we can start to now solidify and say, yeah, you know what? They've mastered this. This is doing very, very well. And then if you need to push them a little higher, you can. Remember that these are the standard dominoes. They go to 6. But you can get dominoes that go to 9s. You can also get dominoes that go to 12s. Probably wouldn't go there with the grade 2s for addition if I'm doing a double-digit addition, but I might use it if I'm just taking 12 and 12 on each side. What's the quick total? 24, right? So I can add the sides of the dominoes together. Okay, so that's kind of one way that I can do some work. The second one was, remember that in grade 1 for fractions, we use the word halves. They never introduced the symbolic of 1/2. That was not part of grade 1, and it's not part of grade 2 until the very end. It's not until we understand what is a unit fraction to begin with. And we did a bunch of that with the Cuisenaire rods. We can do it again. That would be a good time to review. And the Cuisenaire rods have no numbers on them. So I'm really looking at length and how many fit on top, and then what is the relationship between those that fit on top to the one that was on the bottom. A fraction is a relationship, and that's where we start our conversation. We are not interested in using the word numerator and denominator and writing layered numbers because we can. We'll get there, but there's no rush for that. So really, when I look at N3.1, there we go. Fractions can represent part to whole relationships. So that was that dime conversation. We put the 10 dimes on and we said, this is the first out of a possible 10 dimes. Now we wrote it symbolically, but we never named it. We simply said it's the first out of 10 dimes. Here's my second out of 10 dimes. Here's my third out of 10 dimes. So we were expressing a relationship in word form. They also do quarters in grade 2 in word form. So when I'm talking halves and quarters, I need to just give them opportunities to see that in action. I could bring in a watermelon and cut it in half. I could bring in an orange and cut it in half. I could take those, if you go to Dollarama and you get those packages where they have hearts of different colors, they're foam, they've got rectangles of different colors that are foam, circles, whatever, okay, whatever you find in them. I could take the hearts and cut them down with a paper cutter, the foam, just cut it down in the center, so I end up with 2 halves of the heart. So here's my relationship. This is one of the 2 pieces, and together the 2 pieces made one whole heart. You could take a whole bunch of those hearts, maybe take a couple of rectangles. So get the carts cut in half, throw them in a bag. And if they're different colors, that's even better. I could take some of those rectangles and cut them into quarters, have different colors, throw those quarters all into the same bag. Walk around the room, they pull out one piece, and we say, you need to find a matching relationship that you have in your hand. What's matching? And it all goes to symmetry that we talked about earlier as well. So find a partner, go walk around the room until you have one, and then stay with that person. Okay, we want to know, do you have the matching half to the other half? And color is insignificant. So if I had a red heart, you had a green heart, and we found it ourselves, we put them together, it made the whole heart, we found a half. And then later I can tool it up and say, oh, actually to be a really good half, you have to find your matching color as well. So now I'm looking for the attribute of the size, the shape that it is, the matching size, and I'm looking for the same color. If I'm building a square, if I pulled out part of the rectangle that you cut into 4, then I'm looking for 3 other people that have a matching piece that we can create a rectangle with. This is not earth-shattering, but it gets them up out of their seats. It's interactive, it's engaging, and it's modeling that they understand the relationship of the part they have in their hand to building the whole that they have to find their partner or partners to do, right? So that's the important piece. One whole can be interpreted as a number of unit fractions. So we're going to do that as well in just a minute. But a number of unit fractions for the heart, 2. A number of unit fractions for the rectangle, maybe 4, right? Depends on how you cut it. So model one whole using a given fraction, limited to denominators of 10 or less. So we're going to do a lot of paper folding and examples on that. But just to revisit where we have done before, this came from session 3 where we did the money. So this is where we said, when you put it on a number line, that's where the number 0 comes into play, because the minute 0 is included, 0 is the measurement of the distance to your first point. In our case, the first dime was our first point. It was by counting 10 of the cents that were on here, because everything is in cents. And so this was the first dime out of a possible 10. If I did another 1/10 hop, same distance, same length, I hit another dime. So this was the second out of the 10. This is the third, and so on. And as we got to the end is where we got to our 100 cents. So 10 out of 10 dimes. So we also did it for the penny, we did it for the nickel, even though those take us over denominators of 100, or of 10, sorry. It's the context and the understanding that we want to get to. And they're going to do that in grade 3 again too. The quarter is also one that fits to the realm of grade 2. It's talking about quarters. We have a coin that's called a quarter, so they can go find the quarter. And where would I put the quarter on the number line? At 25 cents, at 50 cents, at 75 cents, at 100 cents. So now I see that this is my first quarter jump. My first quarter, my 25-cent piece went here. Here's where my second one came in. Here's where my third one came in, and so on. So again, they're starting to think of it as a relationship. And in this case, how many hops they made, how many quarters do I have in relation to the whole? In other words, 100 cents. So let's unpack those components of the fraction that are in your skill and procedure in particular. Over here, it says the whole can be any size and can be designated by a context. My context and what I just showed you was 100 cents. The context I'm going to show you could be $10. It could be a piece of paper. Let's unpack some of the terminology. Model. Remember that you have to teach the students those verbs. What does it mean to model? What does it mean for me to make a model? What does it mean for me, the teacher, to model? So I need to model a unit fraction by partitioning a whole. So we'll show you a way to do that with students, and also for them to come to some realizations as they're doing that without us telling them the rules. What are unit fractions of an orange rod? So we talked about this before, where we said take an orange rod, and you might want to pause the video and have students even do that if that's where you're at. Take the Cuisenaire rods out again and say, find an orange rod. And then you can layer the orange rod with only one color. Which colors fit on there? Well, the yellow fits on because 2 of those will fit. The red fits on because 5 of those will fit. The white fits on because 10 of those will fit. Each one of those colors represents a different unit fraction of the orange. The yellows, there were 2 of them, so each one of those is 1 out of 2 pieces. The reds, there are 5 of them, so each one is 1 out of 5 pieces. And the whites, there are 10 of them, so that is 1 out of 10 pieces. So I have 3 different unit fractions when I'm using Cuisenaire rods and looking at the orange as my whole. Compare the same unit fractions of different wholes. So we'll do that in our paper folding activity in just a moment. And then model using or given a unit fraction, can you find what the whole would look like? All right, let's do some practice of this first. So if you're watching this video after the fact, what I'd like you to do is just pause it and go and cut out some pieces of paper. Now, they could be just from your recycle bin. I cut just colored paper, I had it handy, but whatever, any kind of paper, it could be from the garbage bin or the recycle bin that you have. I want 8.5, like normal paper size, 8.5 by 11. And then what I did is I cut strips down the long side, the 11 side, and I just made them 1 inch wide. So just go to the paper cutter, cut a whole bunch of these, and then come back and start the video again, because you're going to need a bunch of these because we're going to do them together. Okay, so pause the video if needed. And I'm going to keep going, assuming that you've come back to me. So the first thing we're going to do is we're going to identify what one of those pieces are. Every one of those pieces you cut came from an 8.5 by 11 paper. So they're all the same length. What her color is doesn't matter. So this I'm going to say to you is a whole. So I would like you to take our whole and make a half. And for most students, that they'll handle that, but this is spatial. And even for adults, sometimes spatial visual pieces like this are problematic, and fractions can be problematic anyway. So we have to go slow and we need to give them time. So to make a half, I might do it with them. I'm going to say, well, I could just take my 2 pieces and line them up and fold it. So I have this nice little piece that I've folded in half. So now my whole, this is only half of my whole. So when I open it up, I can see the 2 equal pieces. And if I ask them, how do you know it's an equal piece? They should be able to say to me, well, if you put them back, they fit perfectly over each other. There's nothing hanging out on one, or it's not short on the other, whatever that case may be. All right, so we got a half. I'd like you to open it up. I'd like you to write 1/2 and 1/2 on each side, and then just put it down in front of you on the table. When you've done that, I want you to grab another piece of paper. So I've got another hole, same length, doesn't change. So this time I would like you to make me quarters. So think about how we made a half. How could I leverage that to make quarters? So go ahead and start folding. So I'm going to fold in half. That gives me 2 pieces, but I want quarters, 4 pieces. So if I fold that one in half one more time, that should take my whole strip and change it into 4 equal pieces. How do I know? Well, let's open it up and see. So when I open it up, I have 1, 2, 3, 4 equal pieces. So on yours, I want you to write 1/4, 1/4, 1/4, 1/4. Okay, and just put them down right underneath your 1/2. So you can line up the center ones. So you have a half, right below that you have a quarter. Okay, you guys are on a roll. So let's grab another piece of paper. I would like you to create 8s for me, 1/8. I want to see what 1/8 looks like. So think about how you got to quarters. How could you leverage the folding that you did to get quarters to get to an 1/8? So go ahead and start folding. I'll talk mine through in just a second. I'll give you a second to start first. So I'm going to fold in half. That's 2 pieces. I'm going to fold in half again. That gave me 4 pieces. So if I fold this in half again, that should give me 8 pieces. So open it up and see if you have 8 pieces. Okay, which I do. So label them 1/8, 1/8, 1/8, 1/8. Again, put them below your 1/4. Now, students might start talking and saying, oh, they're getting smaller. If you hear that, try and zero in on the student who said it and just say, can you say that again? What did you just say? They look like they're getting what? They're getting smaller. Oh, okay. Anybody have any ideas why they're getting smaller? The notion is, and remember, a very common mistake for students when we ask them to compare a fraction, if we say, which is larger, a 1/4 or an 1/8? 1/8, of course, an 1/8, because they think in terms of whole numbers. 8 is larger than 4. But when we're talking about partitioning pieces, if I only have to break a whole into 4 pieces versus 8 pieces, the 4 pieces are going to be bigger. Think of cutting a cake. If nobody comes up with the right answer to your question, don't give them the answer. Carry on. Let's try another one. So let's do another one. Grab a piece of paper, my same hole. So this time I'd like you to make tenths or dimes. Can you make tenths for me? So go ahead and start and show me what you're going to do. And you might have a little problem as you start going. So if I think about it, all I did is I took my whole and folded it in half. So if the whole thing was tenths, remember that's what I want is tens. When I fold it in half, that makes this 5. Now that's a problem because if I folded this in half, that would give me 2.5. They're not doing halves, they're not doing decimals. So that's not going to work. But I still want this paper to be tenths. So to get away from the problem that we're in, what I have to eliminate is the odd number. It's the odd number that's causing us the problem. I didn't have that problem when it was 4. That was easy. I could just fold it. But 5 is a problem. So what you're going to do as an adult, not as a grade 2 student pretending, I want you to look at your 5 and I want you to eyeball where you think about 1/5 is and put your finger there. And wherever you put your finger, you're going to fold that piece in. So give your best shot, best estimate, not a ruler, just what's your best guess, how big is a 1/5 on that piece of paper that you have. And just fold it in. So I just took what I guess was and I folded it in. So now what I'm left with is I had 5, but I lost 1 piece. So this is now 4. Well, we know what to do with 4. We can fold it in half. And if I fold it in half one more time, and then open it up, you'll also get a chance to see not only do you have 10 pieces, but how was your guess? You'll see your guess, and was your guess pretty close? Even as an adult, I mean, no one's going to know. And I always say to the students, best guess. And at the end, if your guess was too big or too small, learn from that. Just you eyeballed it and you eyeballed it either too small or too big. So keep that in the back of your mind because you're going to do that again. It's not significant. We're not going to worry about trimming it. What we still want to know though is that we have 10 pieces. And so once you open it up, you'll have 10 pieces. So label each one of these 1/10, 1/10, 1/10, 1/10. So now I might go back again and say, is anybody seeing some pattern happening here? We started with a half, we went to a 1/4, we went to 8ths, we went to 1/10. So somewhere, hopefully they're saying the more folds you ask us to make, the smaller the pieces get. And that's really what we want to get to. We want to hear that from them. We want them to realize so that later when I do ask them a question about comparison, they have something to fall back on. If you say to me, 1/4 is greater than 1/8, and I'll say, no, 1/8 has got to be bigger because 8 is bigger. And you simply launch into a reiteration of, we're not talking about whole numbers, we're talking about parts of a whole. So if I have 8 parts versus 4 parts, the 4 parts will be bigger because there aren't as many pieces to cut something into. That does not necessarily mean I understood what you just said. Because if I don't even understand that the fraction isn't a whole, then the 1/8 argument about 8 and 4 probably means very little to me. So this is a way for us to catch some of those kids before they start making some of those common mistakes. Okay, so let's just say maybe they didn't quite catch on. Let's do one more, and I'm going to give you a really a thought-provoking one. Are you ready? Another piece of paper. So I would like sevens. 7, okay, like 7 units on this one. So now you're probably thinking, okay, this is going like we did the 5s. And you're right, it is. I can't do 7 because if I fold it in half, it's 3.5. I need an even number. So let's ballpark. Where do you think a 7th is going to be on your paper? So figure out where you think it might be, best guess, fold it in at that point. And now I'm down to 6, right? Because you took one away. So now our paper is 6 units long. So when I fold the 6 in half, that's a problem. It's 3 units long. So the rule that you've used doesn't ever change. 3 is problematic. 2 is not problematic. So I'm going to I'm going to ballpark where I think a third is. And I'm going to fold it in again. And now I have a piece that should be too long, which I can fold in half. And now open it up and count your pieces. Do you have 7 pieces? Then compare your estimate. Was your estimate pretty close or was it way off? Okay, and it doesn't matter if it was way off, too short or too long. So count your number of pieces and then label them 1/7. And then we're going to ask students, where do you think this one goes in all the stacks that we have? Where would we put it? So it's going to be between the 1/8 and the 1/4. So the size is bigger than the 1/8, but smaller than the 1/4, right? So they're starting to get how this works. Again, we'd have that conversation. This is a great way for students to internalize what a unit fraction is. And that's what we start talking about. This is the unit. One of these is what we would call a unit fraction of the whole. Now, there's one last one I want you to do. So grab one more piece of paper, fold it in half. And all I want you to do is just tear off a piece of one of them. I just want an end. Not tear off. Tear off 1/2 of this, sorry. So just you fold it in half, just tear it in half. I just want to use one piece. I don't want both halves. So with this one, I'm going to say to the students, oh, new rule, this is our whole. Not this one anymore. Okay, that's not our whole anymore. This is our whole. And can you show me a half with this whole? So they should know, fold it in half. And you'll say, okay, open it up. Do you have 2 pieces? Are they equal? Can you prove to me they're equal? Yeah. But then I might say, well, you know what? I'm a little confused here because if that's a half, how could this one be a half? You said this was a half when we folded it, but now you're saying this is a half. So it's important that they understand that the whole determines the size of that unit fraction. So I can still have halves. It's just they won't look exactly the same size, but the relationship is the same. Both of these, when I fold them in half, represent a piece that lays over another identical piece. But they don't have to be the same length because the original whole was a different length. This is a really, really important concept for kids to see. And not just in grade 2, in grade 3 and in grade 4. Most junior high students and even high school students have not internalized that. It's a tough thing when they think a half has to be just like this. So then you might say, is a half always the same? Yeah, a half is always the same. It's always the same representation, but it doesn't have to be the same size. And there's a perfect example for them. Okay, so just some activities that you can do with paper, but it makes it quite visual for them. They can lay it out on their desk. They can have conversations with their shoulder partner about what's the pattern they're seeing, what's going on here, all the different things that come into play. All right, there's another one I want to take you to, and that is Mathagon. We have used it before. It's not the first time. So if you already have been there, then you'll know probably where we're going to go. I will throw this in the chat box so you can grab it. And so when you bring this up on your screen, this is what you're going to see. And what I want you to do is go to Polypad. Now, when you have time on your own, this is worth exploring, this menu that's on the left-hand side, because each of these has another drop-down menu inside of it. So you've got lots of possibilities that you can use. What I'd like you to do is go to fractions. And we're going to go to, we'll go to fraction. Well, we'll go to fraction circles for now. Now, if your fraction circles came up with numbers on them, you'll see that the number part is highlighted. I don't want numbers on him. I don't want them to see if it's a 6th or an 8th or a 9th. So just hit the last button that's here and it should take away all of your symbols. Now, I could say to students, I want you to pick any one of the bottom 3 rows. Pick one of them from that row, or you can assign them to me or whatever. So let's say I take the purple one. So this is, I'm going to say, this is a unit piece of some shape. Can you tell me what unit it is? Like, what does it represent and what is the shape? So in Mathagon, when you have a shape and you click it on, you'll see you have this little symbol right here. When you hover over, it says copy. So when you click that a couple of times, you get a bunch of the same things. So I'm just going to move some of them off for a minute. So that means I want to build however this is going to look. I'll fit the pieces together. So now I'm going to take this one, I'll turn it, and I need to turn it some more. And I put it together. And I take this one, I'm going to turn it this way. And I'm going to actually need one more. Okay, come on, let's do it this way. All right. So now the students can see it came from a circle. And there were 5 pieces in this circle. So that one that I started with represented 1 out of 5 or 1/5. Now, when you're selecting, a couple of things to point out. When you're selecting which fractions, it says denominators of 10 or less. So I could do every number from 2 to 10. But I'm going to say to you that the context is also important, that you put it in a context for students. And there are 2 fraction denominators in there that we would seldom, if ever, use, and that would be 7 and 9. I'm not saying they couldn't be used. I'm saying they're not the most common fraction that we would use in time. Half is really common, third is common, quarter is common, a fifth is common, 5 20s make 100. So there's a fifth of $100. Sixth, a seventh is not a common number. An eighth is a common number. It's a double of a quarter, but it also goes to grade 3s who are going to do imperial. An imperial measure, the fractions will be denominators of 8, 16, 32. So that's an important one for them to nail down and be able to do. 9, not so much. The other thing I want to remind you of is we have talked about fractions quite a bit in the past. We also did some sessions on fractions, and some of you attended those. For those who didn't, in that research that we looked at for the fractions and unpacking fractions, one of the things that research has shown is that North American teachers, that's us in the US, Canada and the US, North American teachers, and the research explicitly says, have an obsession with circles. When we talk about pizzas, the very first time we bring them up, we go to pizza. We talk about fractions. When we first bring them up, we go to pizzas and cookies. It's the first thing that comes out of our mouth, and it's true. It is true. We do that a lot. The countries in the rest of the world that outperform us consistently in fractions don't start with circles. They're not saying don't use them, and I'm not saying don't use them. But I'm saying if I had done the same paper folding activity with you, instead of asking you to have paper strips, if I said have the same size circle, paper circles, and I said cut them in half, you would be able to fold it in half, no problem. If I said, can you show me quarters? No problem. If I said, show me sixths, that might be a little bit of a problem. There's going to be some estimation involved there. I need to get 6 pieces in the end. If I said, show me a fifth in a circle, that's a hard job because I don't really have a protractor to figure out what angle needs to be here 5 times so I get it right. So I might guess, and I might be kind of off on one, and next piece is a little bit smaller or bigger. And that is their argument. They're saying, why would you pick something that is that shape? Why would we give students a worksheet that has a whole bunch of circles on it, and they're already been divided? And we say, color one piece of each of those circles, and then write in the blank what piece you colored. So we want them to count the number of pieces in the circle. I colored one of those 8 pieces, and I write 1/8. Does that mean I understand that a unit fraction is that? Is that what they think it is? It's a piece I colored in? That's not a unit fraction. It represents a unit fraction. But if I can't build something with a unit fraction, then maybe I don't even understand. If I can't hop by a tenth with dimes, maybe I don't even understand what that even means. So we want students to see a real world context. What do those countries use that are outperforming us? They start with rectangles. Because a rectangle, you just did it, a rectangle, look at how many different units you could create out of them. I could do squares. I could do a hexagon, a regular hexagon, where you can fold lots of corners over in different ways, in different lines. I can get lots of different sides equally there. I could do that with a pentagon. I could do that with an equilateral triangle, right? I can do it with very targeted shapes that allow me to go into multiple different kinds of unit fractions. A circle fits into that work still. It's not that we want to exclude it. It's just maybe we have to bite our tongue when we start talking about fractions and stop saying, you know, when you go for pizza, bring that up after I've done some work with fractions. So now I have a context for it and it makes sense. I hope that makes sense to everybody. Okay, so we've done the fraction piece. Let's carry on. I wanted also to revisit a little bit on the transformations. Remember that when we talk about transformations in grade 2, we're talking about slides, turns, and flips. Can I show them the words reflection, translation, rotation? Yes, you can. They are in brackets. That doesn't mean I can't say, did you know that we have something called a translation? Mostly we call it a slide, and I might use slide for the rest of the time. We're not asking them to write out the word translation. We're not asking them to choose it on a multiple choice test, but it's okay for them to hear it. They just don't need to expand on it. But when I go a little bit further now and I start doing some work, I'm going to be talking about slides. So we have done this before, but what I wanted to do is just give you some newer places to go to if you're revisiting it so that it's fresh. It's a new way. They think they're doing something brand new. It is a new site, but it's not a new lesson. So the first one that is on there, and you'll have these links when you get the slide deck in your folder. So when I go there, I've got all of these different pieces. Now you're not getting into enlargements, so we're just going to stick to reflections, rotations, and translations. So maybe I'll go to the challenge. And we'll get rid of the ads. So in this challenge, for example, it says a blue shape was reflected in a red line and it made a green shape. A blue shape was reflected in a red line and it made a green shape. So if we need to review and we just want to do some quick talking, how do I know it was reflected in this line? What do we know about reflections? Well, if this is the mirror, then whatever vertices or corners of my shape that I'm looking at, this was 2 units away for this corner. So this one to be reflected should be 2 units away. Oh, it is. This one was 2 units away. This one should be 2. Oh, it is. This one over here was 1, 2, 3, 4 units away. So this one should be 1, 2, 3, 4 units away. So this gives me a talking point, right? It's a good model. It's a good example. But now the question said, can you move the red line or draw the red line is really what you're going to do. So they're going to go up here and grab the pen and they can draw it down. It doesn't have to be perfect, but we're looking for the right line. Where would they put another line so that this got reflected and became this? Okay, those are important for them to see. If I go back one, let's look at another one, transformations. This one's a little bit more complicated, but the kids in grade 2 have loved it. So I can tell you it goes over quite well. So here it says, draw a reflection of the shape in the y-axis. So this time I get to make the drawing. So if I did a little bit of work on the other one already, so here's my shape and this is my mirror and I want to make this shape. So how that works is they might say, well, I started with the corner right on the line. So I'm going to put a dot right there. And then I counted 1, 2 to the left. So I'm going to go 1, 2 to the right. So there's my next dot. Then I went up 1 unit. Then I went over further out this way, 1 unit. So I'm going to go out this way, 1 unit. Then I went up 1 unit. And then I went back 1, 2, 3, and I should hit the line. So back 1, 2, 3, and hit the line. Yep. So here is my shape. So it says, if I made a mistake, I can start again. If I want to see if my answer is correct, I'll hit show answer. And where did my answer go? So they highlighted in a darker color, and I see that I'm correct. In the other ones, you'll actually get a check mark, is what you'll see. So although these are weird looking shapes, they're very manageable for the students, and it really gets to the thinking behind what is a reflection, right? How many units away is it from the mirror? On the other side has to be the same. So this is one little place they can go to, and level 1 is probably the most that you would do on this one. And then there's Smash Maths. This is a UK version. F stands for foundational year, which means kindergarten in the UK. Here's grade 1 or year 1. You could go anywhere in grade 2. You could even try some of the grade 3 ones. And just look for the flip slide turn or whatever it is that you're wanting to work on. But in this case, that's what we want. So practice predicting where the flip and the slides go. Okay, practice predicting where the flips and the slides are. So all of these are games, but they're interactive, just kind of the one that we just did. So you'd have to go through them first and see which ones would you like the students to play. But you've got multiple opportunities here. It's not just one that they can go to. And it always goes to the outcome again that the student can actually draw or model or visualize or tell you this was a reflection or this was a turn or this was a flip, right? Okay, so let's leave that one. And let's go to statistics. We left this one for this time of the year because we said, generally it's one we do at the end. I've got lots of tools in my pocket. Then if I need to do adding or something, I can do that. but also it's something that could have fit into your science or social already at this point. So you may have already done it. I do have a suggestion for you on here if you haven't got a project, but I'll show you what that looks like. But let's just look very quickly. What is it that they're supposed to do in grade 2? So students relate data to a variety of representations. So data can be collected to answer questions. So I have to pose a question to collect data or to answer the question. So in grade 1, they learn to pose a statistical question. They gather the data and then they represent it. Kind of like what you're doing, only they're doing a variety of representations. In grade 1, they just do a dot plot. Now you're going to do a variety of different ways. So what might those be? Well, they might be different kinds of graphs, right? That would be the kinds of things we look at. Let's look at 1.1 to relate data to a variety of representations. First of all, they have to collect by asking a question. And then they're going to use firsthand. Remember that firsthand data means I ask the question, I'm collecting the data. I'm generating it by asking the question. I did go to a book and there was already a bunch of statistics in the book and I lifted those statistics and used them. That's secondhand data. All right, so we have to generate a question, collect firsthand data, and then we have to represent that data. Now, if you notice over here in knowledge 1.2, once I've got the data, it can be recorded using tally marks, words, counts, whatever you want, or all of the above, that's up to you. The graph features, you are the grade that will teach students, what do I do when I graph something? It has to have a label, it has to have a title, it has to have things equally spaced out, all of those pieces. This is where they learn that, and it's assumed that from grade 3 up, I don't have to teach that because they already know it. Will I review it? Absolutely, I will. But this is where it's learned, this is where it's outlined in the curriculum. And you're going to be using pictographs, bar graphs, and dot plots. So the dot plots they learned in grade 1. So I can use a bar graph, almost the same kind of thing, or a pictograph if that's what you want to use. In grade 3, just so that you're aware, they're going to actually interpret and explain the data. Now I'm going to go back to you for a second here. If I'm going to give you a question, I'm going to collect the data, I'm going to put it on a graph. I'm really hard pressed to say that we wouldn't come up with some general conclusion. They don't have to do a deep dive into an interpretation. But quite frankly, why would we have them go to the level of creating the data table, showing it, modeling it, displaying it, and then we just walk away? I don't think that makes sense. So even just a concluding statement of, is there one bar that's higher than another? What does that tell us? What do you think that's important about? That's reasonable for us to have. They're not doing a deep dive. They're not doing a huge analysis. They're not doing a range or anything like that. But to have that kind of conversation, I think is very reasonable to finish in grade 2. So in grade 3, they do representations, but they are definitely going into the interpretation and explanation of why they think that might be and how I might read it. Now, there are 2 videos that we're going to watch very, very quickly here. But the first video is really so that all of us come away with the new curriculum in understanding, when I ask students to create a statistical question, are we as teachers all on the same page with what that looks like? So what is a statistical question other than just a regular question? Like right now, I can honestly say that when I go into a classroom, I might see, does anybody have any questions? And all the hands go up. And I already know they don't all have a question. They all want to tell me something. So I'll point at a student and they'll say, did you know, or I did, or so it's not a question. So then I'll take the time, I listen, and I'll say, do you remember what I said when we started? Does anybody have a question? So how does what we just listened to fall? Is it a question or was it information that somebody gave us? So just starting to get them to think about, first of all, what's a question? Now, what's a statistical question? So let's watch these very quickly.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about understanding statistical variability. A statistical question is one that results in multiple and varying numerical answers, rather than just one single answer. Let's look at these questions and see if they are statistical questions. What grade did Hannah get on her math test? Is this a statistical question, yes or no? No, it is not, because there is only one answer. We need many different number answers. Next question, who earned a better grade, Frank or Grant? Is this a statistical question? No, it is not, because it is not a number answer. And finally, what grades did everyone in second period math earn on the test? Is this a statistical question? Yes, it is yes, because we get a lot of different number answers.
Okay, so we should all come away from the same understanding that to have a statistical question, I need to have a multiple possible answers. Can't just be right or wrong, one. And it has to be a number answer. Okay, that's the other piece that I'm looking for. So I can collect the data and do something with that data, plot it on a graph or whatever it is I want to do. So I'm cognizant of time. I'm going to just start a little bit of this one and then we'll stop it. And then I'll encourage you just to finish watching it as you go through.
Hey guys, it's Kaylee. This lesson is an introduction to statistics where we'll cover statistical questions and dot plots. Let's get started. You've probably heard the word statistics or its abbreviation stats before. Statistics help us answer questions like who has won the most times in your video game, or how many times and how fast did I run on different days this week. Statistics is the science of collecting, organizing, analyzing, and interpreting data. In statistics, data is very, very important. But how do we collect data? There are a few ways. We can run an experiment or have a survey. But in both of these ways of collecting data, there is one main thing in common. We have to ask a question. When we ask a question to collect data, it needs to be a statistical question. A statistical question is one where you expect to get a variety or a lot of different answers. Which of these do you think is a statistical question? How tall are basketball players? What time did you wake up this morning? How much money do people typically spend on cars? Do you play soccer?
So I would actually pause the video at this point and let kids see this and just let them even talk with a shoulder partner. So which one or ones do they think are statistical questions? It'll go through and circle it and I'll continue on. So I'll just encourage you to watch the end of it. It goes beyond grade 2, but it's a good refresher for us to make sure that we're all working on the same page. And if you're teaching a split class, then it would be helpful to see how would I unpack the range, talking about a peak or which bar was the highest, or did I see something that happened in my data? And if I do teach a split class, I would simply take the grade 2s along with the grade 3s, because that interpretation piece is not much more of an extension of where you are. Okay.
Welcome to Moo Moo Math and Science.
Hey guys,
in this video.
Sorry, whenever we link them, it always starts. So here's some samples that I put on here. I could say, let's just see again how this might work. Here's our question. What is the most favorite sport of students in our grade 2 class? So maybe this was the result after you did them. So you labeled the sports that came up, use tally marks, because just show them how to collect it and how to record it. And then they can put it into numbers. And then we could even have a conversation. What did we notice? Well, they could say, well, the most was hockey. Most people like hockey. Yeah. But some people only say it was only one more, like soccer was pretty close too. Very good. So just quick general conversations. Or which is the most common type of pet that was owned by grade 3 students? So I've got dogs, cats, birds. either one of these, you could do this as a model in your class, do them up on the whiteboard. If you are in a school that has the brick walls, those bricks are great for building your bar graphs or your dot plots on. So we did that with students. We had a K-12 school. We did that with medals for the Olympics. We put down the top 5 countries, or we even had just medals for Canada and what sports we had them, but whatever. We put the horizontal descriptor on the bottom and the names of what we were collecting. And then the kindergarten students were responsible for putting dots on each of the bricks all the way up the wall. And then the school could interpret those as they walked by. Teachers took those teachable moments to walk by and say, oh, I see the plot. What does it show? Right. So we just did math in the hallway as they walked by. Those bricks are really great. They are an instant graph for you, and a lot of ways for kids that they can use them. They can even have their own section on the wall where they create their own question and model it. And then here's my question. We had some where here's a question. Students could walk by if the students were holding some of their circles to put on, and they would ask the question. Whoever walked by could put their circle on whatever it was. And so we just got some instant feedback regardless of grade. So lots of different ways that we can do this, and the kids can really enjoy getting into that. So going back to this side here, if you have not done a stats yet, you could pick any of those ones that we just did, come up with your own. If you have a special event happening at the school, maybe you could come up with a general survey question that they could ask there. If not, and you want to tie it maybe into financial literacy, these 3 are hyperlinked for you at the store, goods and services, and where do you go shopping. Have a look at them. And is there one there that you could retool a little bit? It meets your financial literacy outcome then, but it also lets you do stats at the same time. So just 3 possible ideas. I'm not suggesting they're the only ones that you could use. So the last slides that you're seeing here are the ones that we've already done. This is the paper folding where you got into a bit of a bind for tenths. So how did I go about that? I folded it in half, then I had to get rid of the 5 by folding it into a 4, fold, fold, open it up, and I get tens. Okay, so I'm going to leave this one for now because we've done these already. And I want to go to resources. So as this is our last session, I want you to have places where you can go to now to either get something that's pre-done where you can do a bit of a test to see how students are thinking or how they're progressing, or just to go get additional resources to do some repetitive work, or I'm not quite at the outcome, I need some more work. So I won't go through all of these, but the NZ Math, we used that when we did Cuisenaire rods. So NZ Math is the Cuisenaire rods that we use with no markings on them. But they also have teaching materials that have already been completed for their teachers. And what they are tasks that you can go in and edit. So if you find one in a particular strand, in this case, that you're looking for that might fit, go have a look. You can edit it. You don't have to use the whole thing, but maybe there's a lot of work that's already done, and that gives you a task that you could give to students. The other one that I want to point out to you, there's 2 of them. Ontario Math, we did look at this one before, but the Ontario Math, remember, had the strands at the top. Because it's Canadian, we don't have to worry about money or something not fitting. I'm going to go into number just as an example. So you have the grades in the columns. I'm looking for something specific. Now remember, their grade 2 might also be in, our grade 2 might also be in their grade 2 or grade 3. So read the descriptor that is in each of the box. And if that descriptor gets to what you want to do with the students, when you click it on, you will be presented with a number of different activities that relate specifically to the descriptor that you just read. You can go through them and pick out what you want to do. Some of them are games, some of them are tasks, some of them are activities, some of them are worksheets, you name it, it's in there. So go through the list and pick out 1 or 2 that fit with what you are looking for. And the last one is LT Squared. This is a UK resource. We've looked at this before when we did number lines. But you can go into resources and explore games. All of these will work. It's also metric because it's a UK. But what I wanted to show you or to pay attention to was the explore column. When I click this one on, this gives you the learning trajectories. And this site is for birth, like we're talking small here, to grade 3. All right, it is definitely a primary site only. And what they've done in these trajectories is, let's say I just want to know counting. How does counting work for a child? They talk about number word sayer. So a parent is playing with them and say, this is your first little piggy, second little piggy. Okay, they talk about words. They're hearing 1, 2, 3. They might just repeat them, but they don't really know what they're doing. And then they get into chanting, and then they get into reciting. So if you have a child right now that's not at the outcome perhaps that they need to be, scroll down into one of these and see where about are they in the trajectory, and what's the next step that I need to do with them. And then go into those and see if you can grab something there that helps you just to move them forward. Or I just want to double check that they know what they're doing. Maybe I want a formative or a quick summative. I could grab some components that are in here. So this has been done for you in every different area that we basically hang our hats right now for grade 2. So I think you'll find that site really helpful as well. The other ones that are listed there are great as well. Now, although it's our end, doesn't mean that you can't connect with me. If you have any questions or you need something before the end of the year, reach out. I'd be glad to share with you anything that I have. Thanks so much for joining me. Thanks so much for being here all year. Hope that's been helpful for you. There will be additional sessions next year, which will be next steps to what we've done. So not a whole series like this. We'll just do them as individually registered sessions, but they will be grade specific about math. And it'll just be to layer something else into the process that we've already got. So we've been through it once. We know next year won't be perfect. So we'll still be doing bridging to a certain degree, but it will be much better than it was this year. And so we're ready to add a little bit more into that already. Also, science is up and running. So if you are teaching science in K-3, those registrations are already open for CARC. So go to the CARC website. They started on April 11th, and you can go in at any time now, register at any time, watch the first session on April 11th, because it's not one we're doing live with you. It is a specifically recorded one. And then you'll join us in grade 2 on the date that we unpack living systems. So between now and June 30th, we will unpack living systems and matter for K-3. K only does matter because there's no living systems. And then when we come back in fall, because you registered, you'll already be part of that cohort, and we will unpack the rest of them for you as well. Okay, thanks very much. If I don't hear or see you in science or in another session, have a wonderful rest of your year and a wonderful summer. Thanks, everyone. Take care.